Okay, waves, question 4. Some students did an investigation to study the behaviour of waves. The figure below shows a ripple tank that they have used to model the behaviour of waves. So there's a plunger, so a plunger is something we plunge, we push it down and pull it up. That then generates waves here. This is water that's in. It's a ripple tank, so yeah, creates ripples. The wave front here, the wave front is a peak. They are the peaks of the waves, so if we're looking down on them. So the shallow region in between, and the deep region over here. Okay, so this deeper region. Complete the wave fronts on the figure above. Okay, on the figure above. Show how the wave is refracted as it passes. So show how the wave is refracted as it passes from the shallow region into the deep region. So refraction is changing of direction. Due to change of speed. It's only worth 1 mark, this one, which I think is quite unfair, really. It's a little trickier than that, this question. So the first thing is, these are the peaks. So I'm going to measure the distance between them, just because I want to make sure that whilst I'm in, it's really a bit hard to tell, it's from the end there. So I know at the moment in the shallow bit, it's going to always stay. Okay, there we go, they're going to stay pretty close. So I know that in the shallow region, they're just going to keep doing the same thing. I'm just going to draw this line down here, to there, and to there. Okay, so the gap between them is the same. It continues going in that direction. I should really make sure I've got that same height, but I would imagine that's probably close enough. So what happens here, the waves are going this way. Now the bit you need to know here is that where does it speed up, where does it slow down? So what we identify is shallow region, there's more friction. So here, the wave is travelling slow. In the deep region, it speeds up. Less friction, it speeds up. Okay, this is why we get the waves, when we go to the beach, the waves always seem quite close together, because when you get if you go from somewhere where things are objects moving fast to slow, they bunch up. So think about watching the Formula One. When the cars are going down the straights, there's big gaps between them. When they hit the corners and slow down, they all bunch up, get really close together. So what we get is here, they're traveling faster than they are here, which means this piece here, so as it's coming along, so this is my wave front moving along, as soon as it hits this point here, the top of the wave travels slow, so that's traveling slow, but this now is traveling fast. So this bottom one's traveling faster, so what's going to happen is it starts to bend in that direction, and that's what we see. The space between these waves gets bigger. I could also have measured it this way. I know that that's the distance between that it should be, but now the distance gets further because they travel further. So here, instead of that, let's go for a hole from there to there. So this one now goes all the way. Instead of there, it goes to here, and there's always going to be this size gap now between the two. And all I do then is I join these dots up. So what we get is we get this pattern here. Making sure that those wavefronts meet. So we get that kind of pattern there. Now, if we know that, and we're happy with that, the wave is still going this way. It's traveling faster here than there, which is why they get that gap there, like you get the spaces increasing. The next question asks us to justify why that is. So explain what happens to the waves as they pass into the deep region. So what happens to the waves as they pass into the deep region? It's worth 2 marks. 1, 2. Okay, and explain is always, it's a describe plus, so describe what happens. So the first part is we know that the wave fronts move further apart That's the first thing. Why does that happen? Well, that's all down to refraction. This is because the wave is moving faster. Okay, so it speeds up. C, the waves generated on the surface of the water are transverse waves. Describe the differences between longitudinal waves and transverse waves. You may include labeled diagrams to help your answer. Okay, so describe the differences between longitudinal waves and transverse waves. You may include labeled diagrams to help your answer. Worth 3 marks. So this is an interesting one. You don't have to for this. So the first thing is it's worth 3 marks. So 1, 2, 3. Longitudinal waves typically are slightly more complicated, but let's go through that in a moment. So longitudinal L, okay, L, I've got those. So longitudinal. So longitude, in L, tude, in L, oscillate in the same direction as direction of energy transfer. Okay, the next one we've got the transverse, T. So now we've got perpendicular and right angle oscillations. It's not all the same direction. So transverse, oscillate at right angles to direction of energy transfer. And we need to get a 3rd mark now. So this is probably where we're going to use a labeled diagram because it's suggested we're going to do that. So let me just sketch out quickly here. So I've got, okay, there's transverse. So this would be displacement. Displacement against time. I've got peak. I've got trough. Okay, so it's doing that. And then here I'd have, so normally we draw these with circles just because they're a little bit easier. Compression, stretching apart, another compression, stretching apart. So here I've got a compression. So this is a transverse wave. So time is that way, transverse. There's a rarefaction. Okay, so I've shown that I've got compression rarefaction, I've got time traveling that way. All I want to do, I'm just going to make sure I know, the examiner knows which I'm talking about. So there's a transverse, that is a longitudinal there. Okay, I might do that, I might describe it, but because they've said I may include a label diagram, I'll probably do a diagram because if they suggest something you may do, it's a pretty strong indication that you should do. I don't tend to, if the examiner writes it down as a suggestion, it's pretty strong, so I'd do it. Okay, hope that helps. Take care.